So this is the last lecture. We're going to go through the last chapter we'll cover. Next week there's no class. I didn't want to cancel the class after that, and I realized I don't have to. I can do it from China. So I'm going to turn on Zoom from China and help people if they want to work on their projects, because that's the last chance to turn in extra credit, unless you want to lose points for being late. So there may be a few people scrambling to do a bunch of late projects. So I will attempt to help them from China. We'll see what comes of that. Well, much more practical solution, if you're worried about your grade, is to get ahead, of course, and I think that's what most people have done. If we look at the scores, I think a ton of people already have an A. Yeah, all the green people already have an A. So that's, if you already have an A, then you really don't need to worry about it, but some people are probably still scrambling to get up to a reasonable grade. So I will see if I can connect. People tell me the internet is pretty miserable in China, so I'm not sure how well it's going to work, but I'll give it a shot. Final exam coming up May 17, 23, available for the whole week online. Tomorrow's Kyle Rankin, a Linux administrator and an expert in Linux, Ubuntu Linux, to talk here, and then Yakub on the 8th, the last visiting speaker. I'm leaving for China the next day, so I'll be gone after that, but I will look at my emails and Twitter and stuff from China and might be able to help some people. I know 2 students with incompletes, and I'm planning to give them to Trinity extensions before I leave, because that just gives us all more time. And I am pretty sure there's going to be no more of these club meetings this semester. I took my own initiative to say those club meetings are called off. I'm pretty sure Dylan's going to be gone next Monday, so he's definitely not going to be doing the server club, and I doubt they'll be doing the CCSF Hackers Club on Saturday anymore. If that changes, I'll put it up there, but I am assuming they're not going to do it anymore this semester. Next semester, we're planning to have a much more professional security club, not just the hackers, that would be bigger than the teams and run by the sort of business security people that will actually fill out the paperwork and get the money from the college and all that. And the competition teams will be really hot next semester with CCDC and CPTC, but they will not be the entirety of the club. And really, they probably shouldn't be the business arm of the club, because the technical nerds tend to never bother to show up for meetings and fill out forms and stuff. And that's fine. That should really be the business side. And our business side with compliance and stuff is increasing. And the job fair yesterday was very successful, and that was the business side. They've got a whole new bunch of employers, and Richard Wu and Steve Nelson and their assistant were there doing an efficient job and organized, which I'm no good at. So it's a step forward, in my opinion. Anyway, so here we are, last bit of attacking other users. So let's talk about some more client-side injection attacks. So here's, if you get data from the user with a form or something, and it tells you what language they want, you put it in the request here. Then that is reflected back to you in response in a cookie, preferred language equals English. Then this is a chance for you to inject extra text in the header of a reply, if they don't filter it properly. So that means, if it's going to let me do it, I could put English, and then I could put HTTP 1.1 here to complete that one, and the host, and then I could complete the rest of the request by controlling, well, this is the GET that goes up, pardon me. The GET goes up and sends the data up, and if I send not just a name, but I send HTTP and carriage returns and more information up, then when I get a reply, I can add a cookie. So now I could have preferred language equals English, and then put in carriage return line feed foo colon bar. So now I've added another cookie named foo with a value of bar that appears to have come from the server. My browser will believe it came from the server, and it did come from the server, but the server didn't intentionally send it. It echoed. It's just like cross-site scripting. I bounced some data off the server. And you can even go far enough to bounce a whole web page off the server. That's HTTP response splitting. But it only works if you can inject carriage return line feed, which is %0D and %0A. And there are some tricks to slide it past, hide them after a null, doubly encode them, and that sort of thing might help. Modern browsers do try to filter these things, or URL encode them, because there was a whole generation of attacks a decade ago of all this happening. So you can inject cookies. Now, if you were able to inject a cookie with like a session ID, that might persist across browser sessions, and we'll talk more about session fixation later. But if I can add a cookie to your browser that appears to come from somebody else's site, I can really mess with you. Like, I can give you a cookie that might conceivably cause your funds transfers at your banking app to go to me instead of who you think they're going to, or come from some different account or something like that. And so if you can inject into the header, I could control the entire body of the. This gives me the opportunity to be virtual website defacement. I can make it appear that the entire web page has changed to a different web page by giving you a crafted URL where you click some bit.ly link, it goes to Amazon, you see a totally different page because it was all actually in that link and bounced off the server. So that's called HTTP response splitting. So I was only supposed to change this author data, but I put in all this stuff. So I put in the content length, the 2 carriage returns, and then the real data, and the content length is set so that your browser will only pay attention to the content I put in, and the real content is down here being ignored. So now the whole website is written by the attacker, and the server believes it served you the website, but you do not experience that website. So this I've got set up. Let me bring it up in Firefox, and I don't think I need burps, so I've taken my Firefox off the proxy, make it easier. And so if I go to attack, or for that matter games, because I don't think I need it to be HTTPS will do for most of this. So here's header injection. So here's the page we talked about. If the language is English, and I submit that, oh, how rude. Perhaps my server is down. Let me find out. Let's see if this goes up. No, that's up. Well, just a moment. It's not listening to me on 8888. Let's see how my net stat is. I should have net stat. Nope, I guess I don't. All right. Not on one of my pages anyway. Yeah. Uh-huh. Well, all right. What a shame. But such is life. Maybe this does have to be HTTP. That looks pretty good. The attack direct. Don't suppose I have it in this one. Nope. Well, fine. So much for that. All right, I had it working, but somehow it's broken now, and I'm not going to try to debug it right now. Anyway, so you can inject that stuff and cause an external page. And one thing you can do, now that's just like cross-site scripting. You send a crafted URL, and it affects the one person that clicks on the URL. But you can, if you have proxies like Cloudflare, although I don't imagine Cloudflare will fall for this, but if you have proxies in the middle, you could send a request, get the response that's going to be split, and quickly send another request and cause it to interpret the second page as tied to the second request. And this is because of the layered model of networking. The high-level processes that handle HTML do not know about the packets that came in. They don't even know about the separate requests. The proxy just sees a flood of requests coming in and tries to match and responses coming in, and they may well be dissociated from each other. So you might be able to poison the cache, so when future people come to see the page, they will all see the poisoned page. That's the trick. And remember, this is why double URL encoding works, because you are probably going through many devices to get to the server, not just directly to one anymore. So that's pretty cute. All right. So I said in the second request, it misunderstands and takes the second response and ties it to the second request. There's an extra response here, which is the real response to this request, which is ignored. And now when administrators come to look at the administration page, they're going to see a crafted page, which might, for example, ask them to give me their password and send it somewhere else. So that's pretty cute. And so the answer is don't put user-controlled input into headers. If you have to do it, then block special characters, like the ones below 20. Which are not printable and contain carriage return and line feed, which are necessary. You have to have carriage return line feed. In fact, you have to have both for modern versions of Apache to be accepted. And then you can modify a cookie. So if the app has something that lets me inject into the header, then I can inject. Now I can create a new cookie. Another thing I can do is maybe I can modify a cookie. It might take the name and value and put it in something like Save User Preferences, and if I'm able to put in carriage returns and line feeds, then I can inject more headers there and set a malicious cookie. You can also do that by cross-site scripting. So if I put a cookie in your browser, I can set it to be remembered forever and applied to other domains. So anything the server can do by putting a cookie on your machine, I can do. by tricking a machine into putting cookie. And this is one of the many violations of the same origin policy. And like everything else in security, the same origin policy was originally created to make browsers secure, saying the cookies can only go to the sites in the same origin. And when it turned out to be completely full of holes and trivially tricked, they all tried to say that wasn't really a security barrier. That's what people say when you break their security barrier is, well, I put that there for some other reason. But that is the main security barrier of the browser, and it is very weak. We're going to defeat it a lot of ways. You could also, if you're not using HTTPS, you can totally put a cookie in by being a man in the middle, of course, and modifying requests as they go by. And even if it, all right, you can set them for arbitrary domains.
Question for you.
Yeah.
If you're intercepting with burp,
Yeah.
and you have a browser open and you're interacting with burp, can you have a second application like Postman in the background and interact with the proxy on burp and have it interpreted as if, like, because Postman you can generate a post with anything in there. You could generate.
Yeah.
Would it?
Well, what is it you want to do?
Would burp allow that traffic to come through and be interpreted as like that's the browser? So you could craft your own header and cookie and everything in Postman exactly how you wanted it.
Well, I mean, in principle, you can run anything through a proxy.
Yeah.
I guess there's probably, I don't know enough about Postman to know if it lets you run through a proxy, but usually everything does.
Yeah.
Because a lot of companies use proxies anyway, so you can even set your operating system to use a proxy, and then the software doesn't even know it's using a proxy.
Yeah.
The OS just routes it through the proxy.
That's what I'm wondering, if burp behaves like it's the browser too, and anything that comes into burp is thought of as.
You can set burp to imitate different things. You can turn on invisible proxying, where it doesn't even change the TTL or appear in the middle. It just hides in the middle.
Yeah.
And that might be the thing to use. But I mean, I think burp can do any of those things. It can also proxy HTTPS to HTTP and the other way. Burp can do pretty much anything, I've found.
Okay.
All right. And there's something there about a secure cookie which I don't understand now. I'm going to skip over it, but as I mentioned, if the cookies are flagged as secure, I don't understand how man-in-the-middle attacker can set a cookie for a secure cookie. That I don't understand. I have to go look at the book to figure out what they're talking about there. Maybe they mean it could be set insecurely and then it would be sent to a secure website. That would happen, but I don't understand if all cookies are flagged as secure. Oh, maybe? Well, I'm just not sure. Anyway, all right, you can have cookie values that do things like turn off HTTPS. Your client-side code may trust the cookie values and display them on the page. So now you've got DOM-based XSS. And as we've seen, anti-CSRF tokens might be in a cookie from a previous page to make sure you're doing the pages in order or something. We can mess with that. If I have a same user persistent XSS, I can use cross-site request forgery to load a script, but I can also put a session token in the user's cookie. Anyway, and then we'll talk about session fixation, which is a curious situation where you have a user connect, you assign them a session token before they log in. And then when they log in, you attach their user account to the existing session token, instead of giving them a new session cookie. This is one way to go. Your session gets elevated. If that's true, then the attacker can set the cookie before the app does. And the app will now take the cookie value that came from the attacker and elevate it. And I know it because I gave it to you. That's why this idea of somehow being reluctant to make a new cookie, but noticing there's already a cookie and sticking with it, creates this same problem. That's session fixation. And it comes, I think, from web developers being shy to change anything. They say, oh, there's already a cookie, some previous page must have said it, I better not mess with it because it'll break what the other developers are using it for on some other part of the page. So that's the game. First, the attacker goes here and gets a token. Then the attacker feeds the token to the user. So I've got a token, I know it's valid because it actually came from the app, I feed it to this user logs in, it thinks it's me elevating, but it's them elevating, and I know the value because I stole it. So that's pretty cute, and that's why the best practice is to, whenever someone logs in, give them a new cookie. Don't elevate their old cookie so the same value has a different meaning. And that's the game. You can feed them a URL with the ID already in it, so when they go there, it will think it's me refreshing my login page or proceeding through the login step. They will not think it is a different person using a cookie that they didn't really get. All right. You can do it without login. Anonymous users, for example, like many most websites, you can browse anonymously, you can fill the shopping cart anonymously, and you don't log in until you try to pay. So they might very well have a motivation to keep using the same cookie through that. And that gives me a chance to steal something and trick your browser into using a cookie value that came from me. All right, sometimes I can submit arbitrary values. It's not even very picky with a checksum or anything on the server. This has happened before, so I can just send you a link with a token without even getting it from the website. I can just fill it in with arbitrary data, and the server will just accept it. All right, so to find this stuff, you just have to see how session tokens are handled. So assign a token to an anonymous user and see if it remains the same value when you log in, and see if a user logs into a second account and changes their identity from one person to another, do they still retain the same token? They might, and if they do, it opens these vulnerabilities. This is what I thought might be going on at Phil's. When I found out at Phil's, I could make 2 accounts with the same email address and different passwords. But I was unable to find a way to exploit it. It's strange, but this is a well-known feature of the Oracle-based stuff they're using. It has an invisible primary key that you never see, and you can have multiple accounts with the same email address and different passwords, and they don't overlap with each other because the email address is not the primary key. There is, and the actual primary key, I couldn't find it in Burp anywhere. I think they never send it to me at all. I log in, they create a key on the server, and I just have a session token that's different every time. But there is some primary index in the database identifying me, which I was not able to ever see or modify. But I could deduce it was there by indirectly. All right, so anyway, I can hijack the session, and even without a login, if I have your session token, I might be able to learn something about you. I found a few of these on Amazon a couple of years ago. I was thinking I might go to the wall sheet with it. It turns out that Amazon sends a lot of cookies unencrypted. But if you get those cookies, I can get your name, and I don't even think I can get your email address. I could get your name, though, because those are what's used to target ads. But I couldn't really buy anything without having to get the other cookies that are always sent securely. So Amazon has multiple levels of security. And I played around with it for a while, and I was able to do a few things that were sort of more than I expected to be able to do, but nothing really terribly exciting, using the kind of cookies that were sent around unencrypted. So if you want to prevent this, obviously you give them a new session token every time they change role. When they log in, when they log out, when they log in as a different user, just give them a different token. And you can have per page tokens as well to make sure they're accessing your pages in order and it's not a bad guy jumping across things. And your tokens should have some kind of checksum embedded in them, like credit card numbers. So if you have a 10-digit token, add a couple more digits at the end that are related to the others, so you can identify numbers that came from you from random numbers generated by attackers. Yeah?
With this notion of session fixation, does it open cookies to brute force attacks if they stay open for that long? Like if you have no idea who the user is, you just start injecting tokens?
That's certainly one. You'll find Burp is well designed for that. If anything is predictable, then that's certainly possible. That's why small numbers are bad. That's why when you look at a professional website, everything is really long. But yeah, if you can predict it, if they're sequential, if they're not random, then brute forcing is often a good way in. And then there's open redirects. These are very common. You have some part of the page that redirects to another page, like the logout button. After you log out, it takes you somewhere. And often that is specified in the URL. You can change it. So you can bounce off the page and go somewhere else. And this is commonly used for rickrolling as a frivolous activity where you click on a link at Amazon and suddenly you're on another page seeing an annoying video. This can be used in phishing as well, and it can be used to do domain name hiding. And this is what recently happened with Amazon and Signal. Signal was hiding behind other companies. They were hiding behind Google and hiding behind Amazon by finding similar vulnerabilities to this. There's a way to make a page that was actually owned by Google but would be interpreted as Signal. So they could circumvent the blocking by countries that want to block Signal. And that is just what malware does. Just what all these attacks do is hide in somebody's site and steal their reputation. Make it look like I'm a harmless Google site when in fact I'm not Google. And I'm operating without Google's permission, putting up code that they didn't approve and they don't really want to be responsible for. So here's the simplest one. These are all over the place. This is the easy way to handle it when you move your website to another domain, like you get bought out or you decide to go to a secure page, you put up a 302 redirect. These are all over the web. It is a terrible practice. It's very convenient, and typically they stay up for years and years. The problem is 302s are typically not secure. So if you have a 302 redirect to an HTTPS site, that is not at all the same as just going directly to the HTTPS site in the first place, because you can hijack it in the original HTTP request, do a man-in-the-middle attack, and send you somewhere else, and you'll never know. So that's why, but this is very common all over the web. Then there's refresh header. This is what people do with amateur sites like blogs where you don't even control the Apache, so you cannot get to the Apache configuration file and specify a 302 redirect, so you put this in your page. This will load your page, and then after a few seconds go somewhere else. It amounts to the same thing. And again, if the first page is HTTP, the second one could be HTTPS, but that does not accomplish the goal of security, not at all, because you passed through a dangerous step on the way to the safe place, and you could have just been hijacked at the dangerous step. And so here's the meta tag, meta HTTP refresh here with a certain amount of time, which can be 0, and then the other page to go to. That's one type of open redirect if I can control that content. You can do it with JavaScript. You can just do document.location equals something if you can inject any code into a script. And so you can exploit these things. Most of them are hard-coded by developers because they've just moved their page to another site, so they're not user controllable. But there's often some kind of return to the original page functionality after a timeout or failure to log in or something. And those often contain user-defined URLs or things that use data from the user to create the URL. This is pretty common. It's not quite as common as cross-site scripting, but it's very common. Hackathon has one. Zap called it remote file inclusion, but it's here. You log in, and after you log in, you put up here where to go to after I log in. And this is intended to go to the home page, but you can make it go to Google. So after you log in, you go to Google. And that's where you see it. You'll just see it up there in the URL or in a cookie or in a field. All right, so one thing you can do is block absolute URLs. This is a common trick since I want to have, the reason I have a variable return is I have conditions. Some users should go here, some users should go there, some users should go here after they're done with this page. Because I might have a login page and I'm going to tell some of them your password has expired and tell others your account is frozen, you can't buy anymore until you pay your bill and things like that. So they try to make a URL that is calculated from data from the user but then sanitized. So you might block any string that starts with HTTP, but you might be able to defeat that with a different version of HTTP like just the // which will have the same effect. Encode the HTTP with URL encoding, put the slashes backwards, put the letters capital, you know, all the usual tricks might defeat the filter, which is probably essentially grep. Another thing they can do is remove HTTP and any external domain, but you might be able to try more tricks like put in HTTP twice, so when it removes one, there's one still left. Put a whole URL in twice, so it removes the whole URL, there's one left. Put an HTTP in the middle of HTTP, you know, all these will tend to defeat sanitization procedures. And then you may verify that the string contains your domain. This is where a lot of tricks have been around for a long time. You can try these, put a funny character in the middle in the second domain. The second or the first one might take effect. There's a real old trick used by phishers where I want you to go to Microsoft.com. So I give you a link that is Microsoft.com@evil.com. And that takes Microsoft.com, interprets it as the username at the other site. But I can make it long so the @ goes off the visible part of the browser bar, so what you see is Microsoft.com. That's an old trick, but it's the same thing here. A person who tries to write a grep filter probably doesn't know all the ways the URL can be mangled, so the stuff that looks like the URL here is not what really is the URL. And you can add the prefix, so it's always got http://company.com stuck in the front of it, so it's going to add. You're going to give me a path here, and it's going to append that to http://mdsec.net. And still, there are tricks. If they forget to put the slash in, for example, then I can just put a dot there instead. And now this is a subdomain of my control, of my domain. So you have to make sure they have the slash in there, and other funny characters can have, like an @ would also work. Anyway, all right, so these open redirects are hazardous, and as always, it's better not to use data from the user and just add it into a string. It's better to make them choose from a list of known good values, that sort of thing. If you do have to, then use relative URLs. This is the wisest thing to do, so it never goes to a domain at all. It just refers to relative to your home of your web page. That would be safer. Make sure it doesn't have funny characters. Prepend every URL with the domain.com with the slash on the end. Verify that it all has that on there. These are good practices, not bulletproof though. HTML5 supports something called client-side SQL, which is sort of baffling, where you're storing a whole database in your browser, not just a cookie, and then accessing it, and you get to it with JavaScript, so now you have SQL in your browser locally to fetch data out of it, and now you can run your app in offline mode with locally stored data, but this also means I can do injection in the browser locally. So I might be able to do client-side SQL injection. Sort of mind-boggling concept, but this will be the stuff stored in your browser in the apps that do it that way. And then I can do client-side parameter pollution. So it loads your inbox with the name, then show folder equals inbox, order equals down, size equals 20. Now I can reply to a message, and down here you'll see action equals reply and a random number and so on. So it uses parameters from the inbox URL, like the size and such. So if I was able to give you a crafted URL to go to the inbox that had a malicious value in the size parameter, I could change that next one. So I can change, you open an inbox with this parameter, action equals delete. Now the reply link will look like this. It'll have action equals delete. And so it'll actually delete messages instead of sending them. And so on, this is the usual stuff. It's all fundamentally the same error we talked about for the whole class, where something is trusted that came from the user. But that's this is the fundamental problem. I mean, I remember there used to be, long ago, we used to talk about our servers and clients. And in the web, every machine is both a server and a client. And if you say which computer is doing the processing, some of it's done here, some of it's done at the proxy, some is done at the router, some is done at the server. It is all over the place. So the question is, how much do you trust anything that comes down the wire? Where did it really come from? Did it in fact even come from the wire? Did it somehow come locally and appear to come from the wire? And that's the confusion that we're exploiting in this whole class. Your browser has a sort of impossible task, given just the data it has, to tell what to trust and what not to trust. All right, so I got some cahoots about that.
Do you have any expectations for DEF CON China?
Not really. I mean, this stuff is pretty much ready to go. I just learned how to translate it all into Chinese. By the way, if I have a student that can read Chinese, I could use a hand. I have used Google to translate this stuff into Chinese, and I have no way to know if it's any good. There's two copies. One is simplified Chinese, and the other is classic Chinese, and I have no clue which one you should use. I use the simplified one, but if I'm supposed to use the other one, somebody that reads Chinese needs to tell me.
I think in mainland China they use simplified characters.
Oh, good, okay.
Taiwan is the classical.
Well, okay, then I might be on the right track. Anyway, this is the thing down here, malware analysis. It's ready to go, and they're going to be doing a bunch of projects down here, and I just made some Chinese links. Now, they won't have access to Google there, I believe, so what I did was I used the Google Translate here to translate them, and I saved a copy of the page and put it on my site. So what you've got here is pages that were translated into Chinese by Google and then stuck on my website. So supposedly these tell you how to do the project. God knows, I certainly don't. I have no idea what this says. This is whatever Google created as instructions for my project. So I've got a bunch of projects, and perhaps this will be easier for Chinese speakers, and perhaps they'll all laugh at me because this is awful and useless. I don't know. But I put it there hoping it will do somebody some good. And if I have a Chinese-speaking student that can look at this and give me some statement about whether you can actually follow these instructions or whether they're just horrible, garbled nonsense, that would be useful.
Well, the censors come after you complete ignorance, and it's completely true, right? And the Chinese censors come after you. Have something
Oh, the
on there.
censors I don't think are a problem. Just the only problem is maybe this is so mangled it's not even good instructions anymore. Maybe one of my students thought I should be using Bing Translate instead of Google Translate.
Oh.
And I certainly can't say which one works better. But somebody that reads Chinese,
But they have a Chinese department here.
I think they do, yeah.
Yeah, right,
Yes.
yeah.
That would be an option. I might just ask Twitter and see if somebody, anyway, I'm inclined, other than that, I'm just going to believe Google. So which one is mostly just a prank? That's open redirects, not treated very seriously like cross-site scripting by most companies. Which one can poison a proxy, so it will affect many users? Okay, that's response splitting. You get to rewrite the whole page. All right. Which one uses the same cookie before and after authentication? Which is kind of unsanitary, as you would think. That's session fixation, good. And which one lets you rewrite the whole page? All right, that's response splitting. All right. So here's some local privacy attacks. Suppose two people share a machine, like in a public lab, or you steal a laptop or a cell phone, so two people actually have the same physical hardware. As we know, there typically is a persistent cookie on there that's good forever, so if they can get past whatever your login to get into the machine, they can totally use all your stored cookies and get on your websites. Now, there's also all this cached data, and this is important both for the thief and for the cops who are looking in. Forensic people do this a lot. What is stored inside your browser? Typically, browsers cache pretty much everything. They cache to make the page load faster. Next time you go back to the same page, they cache images and scripts and all sorts of things. But you can see how things are cached, and this is good, clean fun. So let's do it in Firefox. Firefox is actually very nice. So first I'll clear the cache, which is Preferences, Cache, Clear Now. Okay, Preferences, Cache, Clear Now. Okay, so now the content cache is using 0 bytes of space. There's nothing in the cache. So now I can go to an insecure search, which used to be Bing, but they cleaned up. The Dogpile is still insecure. So if I go to Dogpile, the president is currently freaking out because someone leaked that he uses Propecia. So suppose you find this embarrassing, that you're Googling for Propecia, and you would rather that people don't find this out. You might wonder if that's stored in your browser. And you can find out by going here to about.cache, list cache entries. It's about:cache. Now you can see the cache entries. There are 8 cache entries here storing 32,000 kilobytes of data, 64 kilobytes in use. And you can see the entries right here. It's really very handy. The actual files are sort of binary and hard to read, but you don't need to read them. The browser will let you see them. So here's a Dogpile, 5 kilobytes. Here is Google Analytics. That's ad tracking. DoubleClick is ad tracking. Glogger, who knows what that junk is. Here's more Glogger. But this Dogpile one has the search for Propecia in it, I think. And if you look at this one, you can click it and see what's actually stored in there. This is what's actually in that cookie. And I found the search when I did it pretty easily. Maybe not in this one. Let me look at my slide and see if I can figure out which one I saw. I saw this one. I went to the Dogpile, the one with the search in the URL. Let's see if I can find that one. Because it was storing the term I searched for when I did it. I just had to find the correct, this is the one. So you go to this one, and
Yeah, it's right there.
yeah, it's right there. And if you look in here, it's a get, and there's the Propecia there. And if you go down here, there's more information about it. And there's even a bunch more junk down here, CSS and such. That first one was just the GIF, the fave icon for the page. But anyway, so you can see the cookies, you can see what's stored, and of course all this junk is stored, which is what browsers are supposed to do. One defense against this, however, is if you use secure sites, this doesn't happen. This is a default for browsers. If I go to Google, which is secure, or for that matter, let's try Bing. Because Bing, I humiliated them for not being secure for years, and they actually shaped up recently. So if I go to Bing and I search for cocaine, and I feel like I don't want everybody knowing I've been researching cocaine, then I can go to About, :cache, and oh, I forgot to clear the old data, but let's list the entries and see what we've got. There's Bing, there's something there, but its data size is 0 bytes. Here's something from Dogpile, here's more Bing image archive, 35 bytes, more Google Analytics and Dogpile, and here's another Bing one, suggestions with some of the cocaine in it, so it's not as perfect as it could be. When I did it before, my impression was it didn't store things, but that was Google. This is Bing, which is HTTPS, and yet it's got part of my query there. And I don't quite know what all this garbage is. That might well have more proprietary data, so I'm not sure how perfect this is. And another similar issue is this browser private mode. It's known in Microsoft's browser that the private mode doesn't really stop it from storing stuff. So I mean, there's no reason to believe that it really protects you very well unless you test it. And I'm very skeptical that it can actually protect you. But anyway, HTTPS supposedly doesn't store any data, although it looks to me like the reality is more complicated than that, as you would expect.
Yeah. They really are saying that when you quit out of the browser, it'll wipe what's there. So
That's what they say, but that, as we know, is not true at all if you're using hard drives. The data stays on the hard drive.
Yeah.
If you're using SSDs, it's more true. And by the way, you know, you can't really hide anything anyway because you're using servers and routers and they have logs and they have caches up there too. So, you know, if you want to like use the web and then lie about what you did, good luck. But if you use a VPN or Tor or something, then it gets expensive to track down your data. And so if you're not doing anything too serious, people might not find it worth the bother to prove that you did the bad thing. But it's just that all you can do is make it more expensive for them. So anyway, then there's history and autocomplete. Your browsing history keeps track of everywhere you go, so people often want to clean that. Autocomplete remembers your credit card number, your address, your phone number, and fills in things for you. And that's done by keeping track of a history too. It's stored in the registry. Firefox stores it in the file system. By default, Firefox does not have a master password for saved passwords. So unless you remember to put one in, everybody can just go to the Firefox passwords and just see all your stored passwords. And sometimes cross-site scripting can be used to steal that data. Put up a page that your browser is tricked into thinking is really the page where it should fill things in, and then I can get the information, as you would think. And Flash has these things called Flash cookies, locally stored objects within the Flash plugin. These were all the rage back when Flash was popular, and they're used by a lot of sites to evade people that try to prevent tracking by deleting their cookies. You put these other kind of cookies on there that people don't know about so much, shared between different browsers. Google and many other companies use this. There's a thing called gzapper, which actually removes all the traces that Google put on your machine, or at least it tries to. And Google makes it very hard to do that. They don't just settle for the normal kind of cookies. They have the genius is making another 10 ways to mark your machine that you can't erase, because their whole business model is to know everything you're doing. And Facebook too, really. Internet Explorer has a thing called the userData, which stores stuff, and apparently it captures data even in private browsing mode. Remember, Edge came out in Windows 10. A lot of people started complaining about the privacy consequences of how Edge works. Windows 10 uses a lot of cloud services while you're browsing, so it sends information about your browsing up to Microsoft servers all the time, as well as storing it locally. You know, privacy was not high on Microsoft's agenda. They're just trying to make it work, and what's really high on Microsoft's agenda is somehow getting on phones and tablets. So moving the services to the cloud so your local device can be underpowered is a high priority to them, and they believe with probably good reason that most users couldn't really care less about privacy. Just look at what's happening with Facebook. Users, I remember I used to ride the cheapest airline in the world, forget the name, but they were famous. They charged you for the bag, the seats were cramped.
Frontier?
What was it?
Frontier?
No, it was not Frontier. There was another one that was super cheap.
Southwest.
JetBlue, I think.
JetBlue.
Maybe they were super cheap, and they got more customer complaints than any other airline. And the guy said, "Yeah, I know. They like to complain, and then they come back because what they really care is the price." And they scream bloody murder and complain and put up rotten blog entries, and then they buy another ticket from me because it really is cheaper. So I know what they really want. And Microsoft knows what people really want is for it to be convenient and run on their device and be fast. And this privacy is just something that you can get them mad about for a day or so, and then they'll forget about it and go back to sharing cat gifs again. And anyway, HTML5 has a new bunch of local storage mechanisms, so those will probably create similar issues as HTML5 gradually becomes more popular, and it certainly is getting quite popular now for video. It's pretty much replaced Flash. So there's probably a lot of local HTML5 objects, and I haven't seen a lot of research in it, but it's probably got a lot of the same issues. So you shouldn't be storing anything sensitive in a cookie anyway, because cookies are just not stored safely enough to put anything secret in there like a password. It should just be a random number that means nothing to anybody except your server. It's quite common, as we've said, to in fact encrypt stuff in a cookie instead of using a random number, and that's unwise, because if it's encrypted, it contains information that could be replayed, and there's often a way to decrypt it. Even if you're using good encryption where I can't guess the key or crack it, I can often find another part of your site that will decrypt it for me, or encrypt data I provide so I can guess. Anyway, there are cache directives to tell the browser not to cache it, but of course you have no reason to believe that they will honor that. And the famous example here is the do not track header. Microsoft championed this. Your browser can have a do not track feature, which it tells the server not to put any cookies on your machine. And Microsoft tried to make that on by default, and they put it on by default in Internet Explorer, and then Google just refused to honor it and put the cookies on the machine anyway. Microsoft took them to court, trying to force them to knock that off, and they did not win. But that is a huge issue. Just because you tell a browser not to save it, you have no particular reason to believe that browser honors that. So here's the instructions in ASP to tell it no cache, and in Java to tell it no cache, and browsers that obey instructions will then not cache things. All right, you shouldn't put data in the URL. It should be in the post parameters instead, because the URL is logged in the favorites, in the server logs, and elsewhere, so it's easy to see them. You can also put autocomplete equals off in fields, so it will not automatically complete from the browser, which might prevent some attacks, but it really going to annoy users who are trying to use password managers. All right, and then you can attack the browser. Oh, I thought I had this one coming. So there's logging keystrokes. JavaScript can monitor the keys while the browser is selected. There's a variety of ways to do it. Here's one of them, string from char code. As you press keys, it creates events, and JavaScript can capture those events. So here's a script that worked on old versions of Windows, and Windows 2008 I used in previous versions of the class. You'd type, and it would just put the keystrokes down there. So I was playing with it, and I found a modern version of this that works. So I thought that would be fun. I put that, might as well use this Firefox, I guess. Assuming any part of my site is actually working. There is supposed to be a keylogger demo here. All right, so here's the keylogger. You type in secret information. I'm going to say top secret stuff. And let's put in the time, 6:55 p.m. Okay, so I typed that stuff, and if you go here, now I have a convenient place to put stolen data made for a previous project. So there it is, top secret stuff, 6:55 p.m. I wrote a script that takes anything that comes up, and it always erases the later stuff, so it only keeps 40 lines of stuff. So this is a good place to practice stealing things. So that's how it works. It's just running a script in the header that catches every key press, and every 3 seconds it automatically generates an image and tries to add the image to the page, and the image causes an HTTP GET to go to my server sending the key presses up. This is one of several ways to automatically keep fetching a newly created URL. And the image, of course, gets a 404 in response, but I don't care because my server just harvests the parameter and posts it on that other site. So that's good, clean fun. All right. It works fine in Chrome. Seems like it'll work in any browser. So you can do this. Now, it's only going to catch keystrokes while the frame is in focus. So apps are vulnerable if they embed something in a page. And there's something called reverse stroke jacking in JavaScript, where you're clicking in a frame and I can grab the focus and move it to the top frame above it. We talked about UI attacks before. If you're typing in one box on a web page, there is nothing stopping JavaScript from taking those key presses and applying them somewhere else on the page. Like I just did here, I sent them off to a server elsewhere. So all I have to do is trick you into typing a sentence, and I could pick individual characters out and spell out a command like format C and send that somewhere else. Although I usually don't have a command shell to execute commands like that, but I can be filling in something on another page. And there was an old trick that got a lot of attention a long time ago where you could use CSS to see which links have different colors on your page, and therefore you have visited them. So if I load a page with the top 1,000 websites, I can find out which ones you've gone to. So you've seen these pop-ups that say, "You've been surfing porn, I'm going to tell your wife unless you send me a Bitcoin." They could actually back that up with information about which sites you have been surfing. But this was fixed in 2010 pretty much. It's an old scary attack. They modified the JavaScript functions that retrieve information about the colors on the page and limited them only a couple of harmless things. So there's no longer a commonly known way of doing this. Your browser still colors links you've been to, but it does not send that information up to a server, at least not as easily as it used to. And so I can find out if you're logged into third-party applications. There's no real way to stop this. All I have to do is load something like on a Facebook profile page, and it will only load if you're logged in. And I can just tell whether I got a 404 or not. So that's pretty hard to do. I mean, here you are. So I make a URL that's going to crash, and then on error, it runs a script that sends a signal up to me telling me what the response was. So it's pretty easy to make an automatic script that will find out what else you're logged into, and there's no easy way to stop it. All right. You can even do port scanning. The same origin policy means that I can't see the response, but I can get your browser to make a request. Then data will come to the browser, but I can't send it up to me. But if I get a JavaScript error, then I can detect that. So I can, to some extent, scan your network. Now, you've been here for an hour. Let me see where I am in my slide deck. I think too far to continue. Let's take a 10-minute break. So let's view developer tools, which are somewhere. Toolbars, developer, all right, where is it? Tools, come on, now it's not responding. Tools, web developer, web console, network, and persist logs. Okay, now, if I submit this, it's of course unable to connect because it just exists to drive me mad, but it's lying. All right, so let's see if anything is going to work long enough for me to demonstrate this. Okay, so now I finally sent out the request and got the response. So, I should be able to see the request and the response, and here are the response header is just language of English here. I would like to see it in raw form. Here's raw headers. There's my response, just that. But this lets me inject those special characters. And by the way, no normal web server will fall for this anymore. I had to write my own in Python. So in addition to the network not working, it's a very primitive server you're talking to. However, so you can inject this junk, and this one here will inject character return, line feed, and then another page that just says pwned in big letters, which is an old script kiddie thing to just show that you own them. So if I submit that, now you get pwned, and you no longer see hello English speaker, even though it was in the request. And the reason that happens is because I'm not seeing it in my response down there like I want to see it, but the content length is 28. And the content length was specified in my, if I view the page source, you'll see the only thing you see is pwned and then /h1. But the actual request included more. If I can get back to it there. The actual request included this pwned stuff, and then a couple of carriage returns, and then the HV200 OK to start the next one. So it would have another whole page at the bottom saying hello English speaker, because I can't remove that, but that's all ignored by this browser. And if you want to see it, you can use Chrome, because Chrome does not fall for this. I go to AD, and then header injection, And if I do this injection in Chrome, even though I tell it to only pay attention to 28 characters of the response, Chrome does not listen to me. And when I did it before, it showed me the whole thing, but maybe not this time. Okay, this time it's working in Chrome. So there's a screw loose, and I'm not going to struggle too much because we're going to do another thing which has even more screws loose. So this is the long injection, just to show the kind of evil you can do. And there we are. So I can now add an image. I can demand that you give me your social security number, and none of that came from the server. All the server says is hello English speaker, but that's all off the page. All this is up here. Content link 226, this has the HTML body image tag, and that's what you do. You add a whole other page, and that's what people experience when they go there. So it's good, clean fun. All right, all right, so you can also do port scanning. If you have a Java applet, your browser can scan ports. Again, it can't send the response to the browser, but you can try to dynamically execute script from each one, and you'll get an error message, which again gives you some information. So you can't do a real Nmap type port scan, but you can get some information about whether there are services running on other ports. And some ports are blocked by the browser, like 25, because they're tired of people sending spam email through this technique. Once you identify them, you can try and fingerprint them by looking for known files. For example, if you are scanning a local network, you can look for known devices like Netgear devices and other vulnerable devices by just looking for images that are present on that. After you identify it, you can try default name and password, known vulnerabilities, and so on. There's a lot of these. So this is something I'm getting used to in 140. And in the advanced projects here, on the web, if you do web exploitation, you typically cannot see the answer. A 500 error typically means it's working. It's running a script, putting output somewhere that does not find its way back to me. And that's common. The request is happening, response is happening, but I can't see it. So you can indirectly determine that it worked. So you can send arbitrary binary data to a port with a request that comes from the browser. If you can get someone to go to a malicious page and load a script, but it will always start with HTTP headers. Some services will not put up with that, but some services will accept extra unnecessary data and just ignore it. So those you can still scan and use. All right. So if you, under these conditions, you can bounce off non-HTTP services. If it's running on a port that the browser doesn't block, if it tolerates junk at the beginning of the request, and if it echoes part of the request back, like an error message, then you can bounce off non-HTTP things and have data come back to the browser. And then it will process it as HTML. Browsers are all very tolerant, of course. We talked about this many times. Browsers have no idea what should be on the page. There could be Cold Fusion adds these Cold Fusion tags, JavaScript adds tags, Microsoft Visual Basic adds tags, HTML5 adds tags. Your browser, when it sees something it doesn't understand, it just assumes somebody has invented yet another language to cram into this page without telling me, and just ignores it. So you can totally add extra unnecessary content to anything passing in a web browser, and it will not stop it from working. They ignore the port number, which is good, clean fun. I was doing an attack most of the day getting this one going. So I can connect to another service on a different port number, and if it has the same domain name, the browser will interpret it as satisfying the same domain policy. All right, so that's good, clean fun. And there are, of course, bugs in the browsers, and especially bugs in the extensions if you put in Chrome or Firefox extensions, which my impression is they're less popular than they used to be. 5 years ago, everybody had a dozen extensions. I don't know if that's true anymore. And Java bugs are, of course, Java's quite dangerous. There's a lot of Java bugs, although Java is getting safer now with a lot of sandboxing. So DNS Rebinding is getting a lot of press now. It's a really old attack. This is getting press in the last month or two because of Vincent Treviso at Google that focuses on something. This year he's been doing a ton of DNS Rebinding attacks that are very impressive in his hands, but it's an old technique. And this is why the industry people that came told me I had to teach this course and I had to use that book, because even though this book is 10 years old, everything is in that book. Every time you think you've found something new, it's in that book. And this is in that book, DNS Rebinding. So the trick is you have a server which changes its DNS record back and forth as if it was load balanced, changes it from a real IP address to 127.0.0.1 or something on your local network, so that it confuses your browser. And this is, Vincent Taviso correctly says, this is a time of check, time of use vulnerability. You get a script from samsclass.info, so you can only, that page can only return data that it harvests from other samsclass.info domains. So if I want to steal the password from your home router, which is 192.168.0.1, that is not on samsclass.info, so I'm not allowed to see the data that came from the router. But if I change my DNS resolution to 192.168.0.1 half the time, then your browser will say, oh, they moved that server, it's at 192.168. That is on samsclass.info, so I can take the data from there, and then later on it's back up here, so it sends it back to me. By flipping it back and forth, the browser assumes, the flipping around is intentional, because you could. I'm tired of being at GoDaddy, I'm going to move to another web host with a different IP address, but the browser is dumb enough that it will fall for it flipping every few seconds, which it ought not to fall for. So I can convince it that your local resources are part of my domain, and it's okay to let me see the data it got from them. And the problem with this is a lot of people make services that trust you if you go to 127.0.0.1 or on the LAN. They don't bother to make you log in again. And this dates from the earliest days. I was just going through this earlier. 30 years ago, Cisco routers have a thing called the aux port, because the purpose of it is to connect directly to a phone line, directly into your Centrex system. Because you have a phone prefix and you have all the 4-digit numbers, and one of those 4-digit numbers went to the router to control the router. Typically with no further authentication, because this was back in the 80s, before computers really, before the internet, where it was the only way people could try a lot of phone numbers without dialing them by hand. So they figured if it was not an obvious number, nobody would ever find it, and that's all the authentication you needed back in the old innocent days. And people still have that attitude and have local resources that trust you because they only accept requests from 127.0.0.1. Like Microsoft, ever since Vista has about 30 listening ports on 127.0.0.1. And I don't really know what they're for, and I've never gotten anything resembling a straight answer from any Microsoft engineers I can talk to. But I wonder if Vincent Taviso is going to be making mincemeat of them pretty soon, because they sure do seem to treat 127.0.0.1 as if it was a trusted resource.
Probably APIs that are calling each other through
the network. And Vincent Taviso is going to enlighten them about how going through the network, even to go to 127.0.0.1, is not a secure practice. You might think so. Yeah. It's local, but it's not really local. Anyway, so you can make, so like I say, I trick you in browser into thinking samsclass.info is over here. I'll load the page. Oh, samsclass.info is on the router. I'll load that page. Oh, samsclass.info is back here. I'll send that data back to him. So I can just steal data off your network, and I can issue requests to all these things on your network as if I was local. And this is one thing Kirk came up with a while ago, was showing me that the Comcast has some feature on the web to reboot your home router. So if I don't know how secure it is, but if they made this mistake, I could make a malicious web page that does something to your router when you view it, because it tricks your browser into thinking that your router is on samsclass.info domain. And I've got some examples of this, although not a live demo, as you'll see. This is a very limited attack. It's worse than I thought. I spent like all of last week working on it, and pretty much all of today, and I actually got one to work long after I gave up all hope. This is a very annoying attack. I'm not giving it to you for homework. It's very unreliable, very difficult to do.
Worse than IPv6?
Well, it's like IPv6 in the early days, when after a week of struggle you get it to work once and you can't write down the steps in a way that's going to work for anybody else. But here's what it looks like. I gave up on this and did something else for an hour, and then it finally worked. This is the page Vince Taviso wrote. And it does not work against the target he designed it for at all. But another guy, I can't find any videos of anybody on earth that had a video of it working, not even Vince Taviso. But I found one other blog where someone said he got it to work. So I loaded this thing on a local website. There is something called etcd, which is a very simple database kind of thing that just stores key value pairs and shares them on a network. I don't know why you've got it. It's like, I think it's sort of like a registry, a remote registry or something. Anyway, it's a very simple database thing, and apparently it's quite common. It's used by some network monitoring systems. It's used by when we set up Elk Stack. Anyway, so this is a thing you install on your box, and if you do, it listens on 127.0.0.1 on port 8191 or something like that, and it accepts unauthenticated requests to adjust it because it figures that's okay. So I configured it to listen on 00s on my public address so I could connect it from the host. And Vincent Taviso actually wrote a site, and I can show you this anyway. This part is actually pretty cute. It turns out that the attack is horrible, and you really don't want to do it. But the part Vincent Taviso did is brilliant, as you might expect. He's right at the top of security. Him and Dan Kaminsky, probably the smartest people in the game. They're got to be in the top 10 anyway. So here's Vincent Taviso's simple DNS rebinding service. And I'll start here. This is the blog written by somebody, the only person I can find on earth that actually got Vincent Taviso attack to work. This is why I have sympathy for people who get bug reports. He sent a bug report to these guys, and I highly doubt they reproduced it. I couldn't reproduce it. I spent a whole week on it, but I think they just believed him. But when people say, we can't understand your bug report, we can't reproduce it, that's not because they're stupid. It is really hard. Anyway, so this is etcd. And etcd takes requests, like you curl to 127.0.0.1 on a port, and then it gives you a response in this JSON notation. So here's the action get node directory true. Then his server actually had some stuff on it, like hello world. Mine didn't, so it just gave the early few bits of this JSON showing the server is running. So that is a request made to the server to just show the currently stored data on it. So here's Vincent Taviso actually made a public service which is running and has not been taken down yet, which is kind of amazing, which lets everybody do this easily. And it sounds like he's making it very easy for the whole world to attack people, but now that I've done this attack, I can see why no one bothers to turn it off, because this really doesn't work. But anyway, somewhere, that could be, okay, it's in here. Somewhere is his stinking service. Here, the rebinder. This is what I'm looking for, I think, yeah. All right, this is, okay. So if I want to make a URL, I'll settle for this, 127.0.0.1, and the other address is 192.168.0.1. He made this domain name rebinder.us, and he made it so you make a domain name with the first IP address in hex, and the next IP address in hex, and then rebinder.us. And if you do that, this will flip back and forth. So you can use, for example, host is a simple DNS resolving command line. So if I resolve that, it's 127.0.0.1, and it'll flip eventually, at least it did when I did it before. Maybe it's caching. There is a way to clear the cache. No, that shouldn't be, there, it flipped. Now it's 192.168.0.1. So that's what this thing does. This service he put up will let you flip between any two IP addresses, which is very nice. I tried to do it with Cloudflare by putting two IP addresses on the same domain name, and it answered both of them all the time and didn't give the effect I needed. So now this makes it very easy to make one of these domains that flips back and forth frequently from one address to the other. And the other part is a web page he made, which you can use. And so you load this web page, you connect it to the service on one IP address, and you can even have a different port number. So one of these is your server where you host this page, and the other one is the local resource you want to exploit. And then you run this, and every 20 seconds it will resolve the domain name again and try to send the request to this address. And half the time it'll go to your server and be ignored. The other half it'll go to this request, and when it actually manages to get a response from the local resource, it puts it here in red. And mine actually worked after I gave up all hope. If you're supposed to work in 5 minutes, I think it took an hour and a half. I just didn't happen to close the window after I'd lost. I spent all day messing with it. I said, all right, this thing totally doesn't work. I ran it on exactly the thing that Vincent Taviso gave a report about in exactly the version, and nothing worked. And I said, boy, this really sucks. Anyway.
What version? Or what?
It's some goofy thing called Transmission. It's a BitTorrent client that runs on Linux.
Oh.
And anyway, this is very painful. You don't want to do it. But it does eventually work. If you turn on the developer tools, you can see all the requests it's making. Make another request every 20 seconds, and eventually the stars align and you actually get to steal data. It's not that practical an attack, not a huge risk. But anyway, Beef is similar. I think I took Beef out of this course. I had it in an earlier version. Beef is in Kali, and it lets you put yourself in the middle with ARP poisoning, and then you modify HTTP requests to inject JavaScript into a browser and do things, but almost all the attacks have been fixed and don't work anymore. And of course, as we all know, the whole world has finally had enough of this nonsense, and they're all moving to HTTPS. And the browser manufacturers are doing it, and they are entirely correct. As we've seen in this course, if you aren't using HTTPS, you're just a fool. There are so many things I can do to you. You don't even have any idea who you're talking to, and so everything should just be HTTPS, even just plain pages you're not logging into, to stop all this nonsense, and that's where we're going. And starting at the end of this month, Chrome is going to just mark every site unsafe, and you shouldn't go here if it's not HTTPS, which is probably going to shame people into just now it's free. EFF's free Let's Encrypt service will give everybody a free HTTPS certificate, or now #1 certificate authority in the world. I don't know how they're paying for it, but it's working, so there's not much excuse for not being HTTPS these days. Anyway, and that's the game here. So beef, that'll be pretty much the end of beef on a whole lot of attacks. If everything was just HTTPS, this stuff would become much more difficult. Then you actually have to man in the middle HTTPS, which is not impossible, but it's a whole lot harder. And that's what you want. So if you're in the middle, then of course you can log keystrokes, hijack the session, fingerprint the browser, because you can pump script. You can add JavaScript to every page they're viewing and run it, and it will appear to come from their server because you're in the middle. So you can really do pretty much anything. Although you can't do the last one anymore. Brute forcing their browsing history and sending it back, that's not so easy anymore because they won't let you just see the color of the visited links. So if you're using unencrypted communications, I can sniff it. If you're using HTTPS, but it's not 100% HTTPS, if it's mixed HTTPS and HTTP, that's almost as bad as using HTTP, because if you load like one image over HTTP, I can respond to that and add JavaScript to that image. So it gives me a chance to mess with the page. So, that's why browsers will complain mightily if you have mixed mode. It's got to be 100% HTTPS or you're fooling yourself. So Amazon uses both HTTP and HTTPS. I was pretty upset when I saw this because Google moved to pure HTTPS, but not Amazon. And so, but they do have a whole system of cookies, many different layers of cookies for different purposes, and they have put a lot of effort, obviously, into knowing which cookies should be secure and which ones shouldn't be. So it's working, but it certainly would be a lot cleaner for us to understand if it was 100% HTTPS. But in order for that to work, not only would Amazon have to upgrade to HTTPS, but all their business partners would. All the people putting ads on the site, and that is probably why they are not 100% HTTPS, because it's more important for them to interact with other companies than to meet some mathematical definition of purity. So the man-in-the-middle response can modify anything HTTP. You can reload it over HTTPS. The script will still load. That's the SSL strip attack if I download HTTPS to HTTP. And I can inject script, which will then have access to the cookies. I can still induce the user to make requests to the target domain over HTTP. I can redirect back to that. I can even do what SSL strip does. If the server is 100% HTTPS like Google, I can still serve it up to your browser over port 80 if I'm in the middle. And if you're not using Chrome, it'll fall for it. It will think, oh gee, it's 5 years ago when Google was not secure, because it doesn't know any better. So there are ways to escalate HTTPS access. I can update a cookie that's then used later in an HTTPS request. This is what was coming by earlier. And I'm not sure this is true of all the modern browsers, but apparently you can set a cookie over HTTP and then deliver that cookie to an HTTPS version of the website. I don't think all browsers will fall for that anymore, but some of them probably do. All right, and all right, I think that's it for that stuff. All right, so which data is created by browser plugin? All right, those are the locally stored objects created by Flash. Which one evades the same origin policy? Okay, that's DNS Rebinding. Sounds a lot better than it is in practice. Okay, what's the persistent data you get for HTTP pages but not HTTPS pages? Or so it says in the book. supposedly browsers will not cache anything that comes over HTTPS. And now that the web is going to be 100% HTTPS, I'm not sure what they're going to do about that. But anyway.
Nothing's 100%. Come on, no.
What's that?
Oh, everything's going to be HTTPS. Come on.
It is. It is
There's always be someone that says, I don't want to pay for it.
Yeah, but the browser, there is. That's Steve Gibson, your friend, the GRC. He totally doesn't, he hates HTTPS, but his website is not going to load in modern browsers quite soon. So he's going to have to knock it off. By the way, I went to a European IPv6 site when I was teaching the IPv6 class, and there's some guys there like him that are still using whatever was before HTTPS. There was a rival encryption service, and they're the hardcore people that never let go of it. They think it's better than HTTPS, so the only way to load their web page is to get this weird browser. Because they're using some non-standard encryption thing, and you can't even go there unless you go get the weird browser extension. And because they're still clinging to the better encryption method.
Betamax.
Yeah, the Betamax, exactly. Anyway, so which one lets a script in a frame grab input from the containing frame?
That sounds like a good security measure. You don't want people to see your data except for the people who have your plugin.
That is security through obscurity,
Yes.
but it's true. It's like putting your website up in a dead language or something.
Yes.
You're only going to reach, that's true, it will present a lot of attacks. That's called reverse stroke jacking, one frame grabbing data from another. All right, which one is only possible if the target processes ignore extra data? Which is, like I say, I came from compiled languages like Fortran. The web is unbelievably sloppy. What is this? Letting you put extra data and not just giving an error message. No wonder everything goes to hell. And that's the non-HTTP services, which will still let you send HTTP requests because they are tolerant. So, it's Matthew and Ward and Jeff Tom. Good. All right, so that's it. I've run out of things to teach you. So no class next week, and May 16 is the official last class, and I'll only be there to help people if they have questions, if I can connect from China. People are talking about how I have to get a special SIM chip and a VPN and all this jazz, so God only knows to what extent I will actually be able to do anything from China. We will find out.